My name's Abigail Harrison from the University of Connecticut, and today I'm going to be talking to you about adaptive risk-limiting comparison audits. So to start, what is a risk-limiting audit, or RLA for short? An RLA is a statistical post-election audit with the goal of verifying the outcome of an election by re-examining cast ballots. I really want to emphasize here that an RLA only checks the election results. It can't actually change them. So it gives out two results. Either election results seem correct, in which case you're good, or they're inconclusive. And in that case, we need to conduct more auditing to determine the correct election results. The procedure involves selecting a random sample of ballots, so there is a risk or a chance we won't find an error in the election results if there is one. So when we say it's a risk-limiting audit, we mean there's an explicit bound on this risk. There's three methods for a risk-limiting audit. The first is a hand recount. This technically has no risk because you're literally looking at every single ballot cast in the election. This can take weeks to complete. It's super costly, so it is not an ideal method for auditing due to time restrictions on reporting election results. The other is ballot polling. This is pretty intuitive. You take a sample of ballots, you tally the results from that sample, and you compare your tally to the election results. And I've attached a paper that gives more information about ballot polling. Then there's ballot comparison. Two methods of comparison audits, ballot and batch comparison. I'll be talking really in depth about ballot comparison. However, batch comparison has the same inner workings as ballot comparison. The difference is you look at a grouping of ballots rather than individual ballots. The overarching assumption of these methods is that ballots are verified, known, and fixed. They're immutable records of voter intent that cannot be changed once they are cast. So a few requirements to conduct an RLA. The first is physical paper ballots. These are the ground truth of the election due to the assumption that ballots are known, verified, and fixed. The next is a ballot manifest. This is a list of every batch in the election and the number of ballots within that batch. This can be a set number, such as 50 and 100, or it could be an arbitrary number, such as all the ballots from a polling place. Tabulation totals are what we're checking in the election through the audit. These are the number of votes for the winner and loser of the election. And then finally, for comparison audits, you need a cast vote record table, or CVR. There's a picture of a CVR attached there. A CVR is essentially a list of every ballot, an identifier, so you can relate a ballot to a corresponding row in the CVR, and then the vote as marked on the ballot. So as you can see here in our first contest, every ballot voted for Mickey Mouse. So the procedure for ballot comparison RLAs. You have your trusted auditor in your election, denoted by the world here. We are essentially checking information coming from the election. The election is not necessarily adversarial. However, we do not trust the information coming from it, mainly due to the fact that machines are involved, and machines can have malfunctions, miscalibrations, so we need to look at the information. So the trusted auditor receives the ballot manifest from a trusted source. That's a list of every batch and the ballots within the batch, such as if they made it themselves. And the election is in control of the physical, untampered ballots. Remember, they cannot be changed. So to start, the election gives the reported winner and loser via the tabulation totals to the auditor. Then the auditor sends a request for the CVR, so the list of all the ballots and the interpretations. The election then assigns ballot identifiers to every ballot. This is the only change the election can make to ballots, and they cannot change identifiers once they are assigned. So after those are assigned, they respond with the CVR, and then the auditor requests a specific ballot. The election responds in turn. The auditor interprets this ballot and compares the interpretation to the row on the CVR. They then repeat this process of requesting and receiving specifically ballots until the audit concludes. And again, there's two conclusions: either election results seem correct, or we need to do more auditing. So what's the problem with this procedure? In Connecticut and many other states in the US, we use machines called voter-facing tabulators. For those of you who don't know, voter-facing tabulators is when a voter walks into the polling place, they fill out their ballot, and they give it directly to the machine to scan. These machines do not maintain order to protect voter privacy. For example, say I knew you were the first person to vote at a specific machine. Then I would know that the first ballot within the machine is yours if they maintained order. So to protect voter privacy, these machines shuffle thousands of ballots together. Therefore, producing a CVR that enables uniform ballot sampling is difficult with voter-facing tabulators. For an audit, you need to quickly find a particular ballot, and if they're shuffled together, this is essentially a linear search. Another problem is existing legacy tabulators do not produce CVRs. The Election Assistance Commission recently put out new guidelines that require new tabulators to produce CVRs. However, we expect it to be a couple of years before these are readily available on the market. You can circumnavigate this problem using transitive CVR production, where you take your ballots to another machine, and that machine produces a CVR. However, this is very, very costly. In Connecticut, we ran a pilot of risk-limiting audits, and we used transitive CVR production, and overall, we found this to be 99% of the audit cost. So our goal is to reduce that cost. Our proposed solution is called adaptive risk-limiting audits. As I said, the goal is to reduce the cost of CVR generation when you need to use transitive CVR production. The way this differs from normal comparison audits, that procedure I just described, is CVRs are only generated for specific batches rather than the entire election, and I'll get into that in a second. So, in other words, our goal is to only generate portions of the CVR necessary to get the statistical guarantee from an RLA, and allow for adaptive generation, which is necessary if we need to continue auditing after our first initial round. We found that it improves efficiency in distributed elections without CVR generating tabulators. I have attached a table that unfortunately I can't get super into due to time. However, I just want to point out the percent CVR column. In Connecticut, at a 1% margin of victory, through our method, you only generate about 78% of the statewide CVR. However, in Florida, where you're pulling the same number of ballots, but the state is much larger, you're only generating 22% of the statewide CVR. So that is a significant cost reduction in what we believe is a large cost of the overall audit. So for our adversarial model and assumptions for adaptive RLAs, our auditor and election changed to auditor and adversary. Our first assumption of this model is that the auditor knows the hand count of each batch, also known as the ballot manifest, similar to the normal ballot comparison procedure. And our second assumption is that ballots are fixed, including labels. This goes back to the overarching assumption that ballots are known, verified, and fixed, and once the adversary assigns identifiers, they cannot change them. So to start, instead of tabulation totals, our adversary is giving batch subtotals, so the number of votes for the reported winner and loser within each batch, instead of the entire election. The auditor then sends a request for the batch CVR. The adversary responds identifiers to the ballots within the batch if they're not already there, and responds in turn with that batch CVR. The auditor needs to make a series of checks on the CVR. This is part of our adversarial model, so these checks include mainly ensuring that the number of votes for the winner and loser match the number of votes for the winner and loser as shown in the batch subtotals, and they need to ensure that there's no duplicate identifiers on the batch CVR, and I'll get into that information in a second. So, then the procedure is the same as a normal ballot comparison audit. The auditor requests a specific ballot. The adversary responds in turn with this ballot. And our third assumption of our model is that the auditor can determine the identifier and on the ballot and the vote pattern on the ballot. So then they interpret this ballot, they compare it to the corresponding CVR row, and they repeat this process of requesting and receiving specifically batch CVRs and ballots until the audit concludes. Note how this differs from the normal ballot comparison procedure, wherein you only generate one CVR for the entire election and then repeat requesting and receiving ballots. In this case, we do it specifically with batch CVRs and ballots. So, what's the purpose of those CVR checks I mentioned? Real fast, the definition of discrepancy, which I'll be talking about, is the difference between the vote as interpreted by the machine versus on the actual ballot. So, a discrepancy of 0 means that the CVR or machine shows a vote for, say, the winner, and the ballot shows a vote for the winner. Same for the loser. It shows a vote for the loser, the ballot shows a vote for a loser. A discrepancy of -2 could mean that the CVR shows a vote for the loser, but the ballot shows a vote for the winner. And there's other cases of 2, -1, 1, etc. So the first check was to ensure that the votes for the reported winner and loser match those on the batch subtotals. This is to ensure that the batch CVR has the same discrepancy as the tabulation. So essentially, we make the batch CVR a representation of how the machine interpreted ballots in tabulation. So the difference between tabulation and ballots should be reflected when you compare ballots to the CVR. The next check that we made was ensuring that there's no duplicate identifiers on the CVR. Imagine a circumstance where the adversary assigns the same identifier to physical ballots and then gives any ballot it wants when you request that identifier. On the CVR itself, we do a check to ensure that even if physical ballots have the same identifier, the CVR does not. It's a little complicated, so I don't have time to go into it, but in our paper, we do ensure duplicate identifiers do not weaken our method, and we contain a full analysis of the influence of duplicate identifiers for both adaptive and conventional audits. So, in conclusion, the main advances of our paper are we generate batch-selected CVRs only as needed to conduct an audit. We give a formal modeling of RLAs beyond the statistical test requirements, and we explicitly handle this question of identifier uniqueness, which has not yet been done before in RLA literature. What this means in practice is cheaper comparison audits for states without CVR-producing tabulators, such as those that use transitive CVR production, and less ambiguity and discrepancy-related decisions, as our paper actually handles what to do when those CVR checks fail. So that concludes my presentation. Thank you for your time.
Any questions from the audience can be asked either coming up to the microphone or over the online platform.
I'm very curious about the duplicate identifiers. How does the verifier know that which one is duplicate and which one is realistic? So can you elaborate on that?
Of course, yeah. So the easiest way to check is a CVR is essentially like a spreadsheet, right? You have your column with the ballot identifiers, and because it's a spreadsheet, you can just easily look at what identifiers are duplicated in that specific column. In the chance that the adversary did assign the same identifier to multiple ballots, and that shows up in the CVR, you essentially change the CVR identifiers to make them each unique. And then if you're interested, I can briefly talk about how that affects the audit itself, but that's how you'd handle that situation.
Right, so in my understanding, basically the initial assignment that is non-duplicated basically exists with the verifier, right?
Yeah.
Okay, thank you.
Any other question? If not, I have a quick question. At a very high level, this significantly improves the performance, but generally performance has a security trade-off. So maybe can you talk a little bit more about what are we giving up in this method in the higher level scheme of things?
Of course, yeah. So essentially, when you are conducting a normal ballot comparison audit, which has proofs and all that for security, you are only looking at very specific portions of the CVR rather than the entire CVR, because you're pulling a random sample of ballots and therefore only looking at those corresponding rows. Our method essentially just cuts out the parts of the CVR you are not going to be looking at ever, and instead generates CVRs only for the ballots that you're going to be looking at, or the batch for ballots which you're going to be looking at. So it follows the same proofs as previous ballot comparison audits. Essentially, you are just cutting down the unnecessary information.
That sounds great. Any other questions? If not, thanks for the talk.
Thank you.